Okay, we're going to do Algebra 1 review over Chapter 2 to catch some things that you had difficulty with or may have difficulty with. Now, I want to caution you as we go through because I'm calling this review, but these are problems that you have missed, and we need to get them corrected. I don't want your your grade affected by this. We have a bunch here that need to be addressed, so you need to pay very close attention to what you're writing down for these answers, because there's no mulligans or redos on any of this. So if you don't sure that you're on the right track with something, you need to stop and make sure that I can help you as you go through. Do not rush. Take your time. You need every one of these to be correct. Okay? So go through it. Do it as quickly as you can, but don't rush and don't dilly-dally. I'd like to get it all done in one day, no more than 2 days. I'm watching the Packers-Cowboys game, so you may hear screams from my husband, or you may hear me scream. We'll try to see how far we can get. So some of the instructions that were in Lesson 2.6 read, use distributive property to rewrite the expression without parentheses. I used an example, problem number 17, which was found on page 104. We had 3, and in parentheses we had x plus 4, and then we work that out. We have 3x, once I put it, plus 3 times 4, 3x plus 12. That's as far as you could go with that one. But you have to write it exactly. Now this one I could have done 3 times. I just went ahead and combined the 3x because that one was obvious. But that's what it looks like in that case. Don't ever have like 2 x's like this together. That would be either 3 times x in parentheses or 3 times 4. But this is, don't use the 2 x's together, but use parentheses to signify multiplication. Here's another one, another problem. We have 5 times w plus 6. This was in parentheses. We distribute that property out. We have 5 times the w in parentheses plus 5 times 6 in parentheses. And then we have to go one more step, which is we have to solve it. And so that becomes 5w plus 30. So always try to go as far as you can, just in case you misunderstand the equation, or simplifying sometimes lets someone think that all I got to do is go one step, and you really need to go as far as you can. And just as a little side note, you're not going to get deducted for going ahead and solving a problem if in fact you just went farther. So you're always safer to go farther. We have next problem in the same lesson. We had in parentheses 9 plus 3n, end of parentheses times 2, and so I just distributed the out. So we had 2 times 9 plus 2 times 3n, and the 2 times 9 equals 18 plus 2 times 3 is 6 in the n, and there's nothing more to do with this problem, so that one's through. Another one, number 28, we had 1/5 times 10 plus 15r. We redo that, rewrite it, distribute it out. It's 1/5 times 10 plus 1/5 times 15r. When we divide that out, we get 2 and 3r. If you don't know how to divide this out or how I got the 2 and the 3r, you need to stop and ask me to show you. The next instruction is to use distributive property to rewrite the expression without parentheses. These are subtraction problems, while the ones before this were addition problems. In this case, we had 5, and in parentheses, y minus 2. When we distribute that out, we get 5 times y in parentheses minus 5, in the 2 in parentheses. I can continue down, and I have 5y minus 10. That one is finished. In another example, we have x minus 2 times 2, and we'll end up with 2x and negative 2 times 2 here. We can work that out, and we get 2x minus 4. Another problem we have in parentheses negative 3.1u minus 0.8 times 3. We distribute this out and we have 3 minus 3.1u minus 3 times 0.8. We continue to finish our multiplication here, so we end up with negative 9 minus 2.4. Again, that was just a multiplication of 0.8 times 3 here. Next problem, we have 5 times 1/10 times, 1/10 x minus 2 over 15. We distribute that out, the 5 out, so we have 5 times 1/10 x minus 5, in parentheses negative 2 over 15. We multiply that out, and we get 1/2 x minus 2/3. We have some more problems. These are the same as we did, but this time they have maybe 2 minus signs in the problem, or a minus and a plus, and you just have to change the sign depending on what the problem. Here we have negative 3r plus 8. We distribute that out. That's negative 3 times r plus negative 3r times 8. The 3r, we have negative 3r here, plus negative 24. We multiply this out. A negative and a positive, we remove the positive, and we end up with negative 3r minus 24. We have the same, another problem here. We have negative 2x times x minus 6. Distribute that out, and you have negative 2x. That's negative 2, comes out to be negative 2x plus 12. The two minus signs here equal a plus. Positive sign. Down here we have negative 3/8 times x plus 24. Negative 3 over 8 times 6 plus negative 3 over 8 times 24. That works out to be negative, something came on the screen. Negative 3/8 times 6 minus 72 over 8, which equals negative 3/8 minus 9. If you're not sure how I got any of these numbers, you need to ask me to make sure that you understand. I don't know why it's so dark, but it just is. Now here's a set of instructions in that same lesson. Oops, sorry, I thought I had the arrow key. Use distributive property in mental math to simplify expressions. Here we had 54, that was problem number 54, is 4 times 6.11. That's just a multiplication problem, and you come out with 24.44. Same on number 56 here, 10 times 7.25 equals 72.50. Here's a problem that you missed. I want to go over. I'll give you a different problem to redo, but it was 10 times 8 over 4 to the second power times 4. 4 squared times 4, which equals, just to rewrite it in parentheses, 10 times 8 and 4 squared times 4. When we times each side up and down, when we multiply, I can't talk all this time, multiply it out, we get 80, and then we have this to multiply, which is 16, and then put the 4 there, we can multiply that out, and then we end up with 80 over 64. Then we have to find out what number goes into, what same number can go into that. I can multiply each side, so I can break it down. So I can say 64 is 8 times 8, and 80 is 10 times 8. The 8 can be divided into both of them. That leaves me with 5. 4. I could have done it with 16 times 5 and 16 times 4, and that we get to the same number. Okay? In this example, we had 75 minus 5 squared over 13 plus 3 times 4. So to start working it out, we had 74 minus 25, 5 times 5 squared. 13 plus 3 times 4 is 12. We have 50 then over 25, and then we figure out what same number can multiply into both. That would be 2 times 25 is 50, 2 times 1 is 25 times 1 is 25, and then that clearly is just 2. On another thing that you had problems with was on quiz 2, which was on page 106. You kind of did the same thing. It's x plus 2 times 11. 11 times x plus 11 times 2 is how we distribute it out. 11x plus 22 is the what you end up with. Here's what I want you to do for assignment 1. Is on page beginning on page 103. Do these numbers, not number 28 here. I didn't mean to have you do that. Do each of these, and then on quiz 2, page 106, do numbers 15 and 16, and this is due today. And just to remind you, all this is due today. If you get through before the math time is up, start on the next part on the same video. So we're going to jump to 2.7 review, and this this chapter, or this lesson, was identify like terms in an expression. So like terms would be negative 6w, 3w. Those are like terms. There's no other anything like 12, and there's nothing like 2w to the second power. So those would not be like terms. And so in this case, the answer would just be 6w plus 3w. So in another problem, number 20, we had negative 6w, oh, sorry, wrong one. We have 3x squared plus 4x plus 8x plus or minus 7x squared. These two are like terms. They both are x squared. These two are like terms. Okay, so in the next instructions are simplify by combining like terms if possible. If not, write already simplified down. Number 28 is an example here. It's we had 6a minus 2a squared plus 4a squared minus a squared. And you can see then we combine the like terms, 6a plus the 4a, 2a squared plus a squared, and I just added the 1 there so you would remember that that's a 1. Then we continue. We have 6a plus 4a is 10a. We have negative 2a squared plus negative 1a squared, and that comes out to be negative 3a squared, and so it's 10a minus 3a squared. On page 110, number 30, the instructions were to simplify the expression, and the problem was negative 10 times b minus 1 plus 4b, and we simplify it, we have, or distribute it, we have negative 10 times b plus negative 10 times negative 1 plus 4b. We continue to work it out, and we end up with negative 10b plus 10, because negative 10 times negative 1 is positive, plus 4b. We now put like terms together. Negative 10b plus 4b is going to equal 6b, and plus the 10, and this is our answer. On number 38, in the same, doing the same kind of thing, we had 4, in parentheses, x plus 2 minus x plus 2. We distribute it. We have 4x plus 8, and I added a negative 1 here just because it's easy not to realize that it's here. We had negative 1 times x plus negative 1 times 2. We combine like terms, which would be the 4x and the negative 1x, and the plus 8 plus the -2. I included the extra plus signs here as we worked it through just so you can see, and we end up with 3x plus 6. Okay, and your assignment 2, which is on page 110, is to do problems 15 through 19, 21 through 26, 28 through 29, and 30 through 36. If you're, you need to work the full hour, so if you finish with the assignment 1, then you would have continued to assignment 2. I'd like to get as much of this done in one day as possible. So let's take a look at what we got here. Again, I rewrote the problem. I just rearranged it slightly. Negative x minus 7 plus x plus x plus x minus 7 plus x. And I rewrote, separated all the terms out. So I had x plus the -7, brought down the plus x here, plus the -x that's here, plus x is right there. I combined all my like terms, so that's 4x, and then the -x plus the -x is plus -14, plus, and a negative is negative, so 4x minus 14. Now, the first thing you need to do to solve this problem is you have to identify the elements. We have 150 train of cars. We have 2 types of grain. It gave us the number 90.25 tons per car of barley, or 114 tons of corn, and N equals the number of cars carrying corn. So what you want to do is solve for a formula that has the number of tons for barley, so that would be the 90.25 times the number of cars altogether, and that was 150, minus N, which is the cars carrying corn, we don't know, plus how much the tons of corn we have, so it's 114 per ton of corn, times N, which is the number of cars carrying corn. And you solve it that way. And our answer would be A then, 90.25 times 150 minus 9 plus 114N, and the answer is A. I mean, that's the formula that will get you the answer to number 45. Now 46 wants you to simplify the expression, the correct expression. So if you selected the wrong one originally, you're going to be out of luck on this one too. So we would multiply out 90.25. See, 90.25 times 50 plus 90.25 times negative N plus 114 times N. That would be 13,537.50 is what that, when we multiply this together, plus, this was a negative here, 90.25 N. I don't need the parentheses. I don't know why I wrote that like that, but just because I had the negative there. And plus the 114N then we can figure out how to redistribute this n here by pulling it out. 25 plus n, kind of working backwards then, and then we can solve for this. Let me rewrite, I have to go to the next page, sorry. We end up with 13,537.50 plus 2375n. So that would be the answer to number 46. And then number 47 is basically asking you to replace the n, if I could write, replace the n with 90, because that's the amount that it gives you of the number of freight cars containing grain. In all of these, we were trying to figure out the weight. Even 45, we actually had a W equals. 46, we're going to have a W equals. 47, we're going to have a W equals. We can take the number that we came up with up here as that second part and do 2375. We don't have to use the n here. We can use the 90. Add back in. So we basically are solving for the problem before it, and that's what these series of problems are based on each other. So if you get one wrong, you're going to be out of luck. One step wrong. Then we multiply that out. That stays the same. And then W equals 15,675 tons. The next one, it was maintaining skills on page 112. And this one is rather hard and very tricky. If you are ordering on a number line, and they're all the same fractions, as in you're trying to do that's something like 2/10, 4/10, 9/10, 5/10, 6/10. That's easy to order on a number line. But something that has different fractions, where we have 3/5 times 2/3 times 3/3 times 7/3 times 3/8, can be more difficult and more confusing to do. Now, what the easiest way to do on some of these you might be able to use mental math, but is to convert it to a decimal. And just as a review, if you have 3/8, that's really a decimal. I mean, it really is a division problem. We have 8 into 3. Can't do that. We're going to have a decimal. And the answer up here is then going to be what your decimal is. Your answer here is the decimal equation it's equal to this right here. So you can turn any fraction and get the decimal equivalent. In this case, it would be turns out to be 3.75. And we can turn 3/7, which was another one of that. We can divide it out using the same method, and we're going to get something like 4.285. We can do the next fraction, which is 5 to 3. We're going to get 6.6. And we continue on, we get 1, and then the last fraction of that series, which was 3 over 2 we know is the same as this, and we already know by looking at this that that's going to be greater than 1, which was the fraction that we just did. So that one would be 1.5. So in most of these, if you turn it into a decimal and to check your whether or not you're ordering it right, you're going to be far better, and it's a great way to check it. And certainly the last 2 or 3 of them, if you don't turn them into decimals, you're going to get them wrong. So let's look at another problem. This is coming from page 1116. And it's number 27, and the instructions were dividing real numbers and finding the quotient. And so the first problem, or this number 27, was 6 divided by 1/2. And to do that, you have to multiply by the reciprocal of the divisor, not the dividend. So that means we would have 6. I'm just going to put it over 1 just to make it so times 2 over 1. So it's the reciprocal of this. I just added this just to make it clear what we're doing. Is going to equal 12 over 1, and of course we don't need this then, and our answer would be 12. So make sure that you're doing that correctly. Sorry, it's like not behaving at all. Okay, now just for reference, if you were asked to simplify the following expression, it was number 48 on page 17, negative 56 plus h over negative 8. And you can't, this is already simplified because, hang on, it's already simplified because there's no coefficient. Other than 1, I mean, we'd have to say maybe there's a 1 here on the h term. So we can't simplify this particular problem any farther. So the answer on this one would be already. Simplified. So let's look at another one on number 46. I think this one would be on page 117. It's 45 minus 5n over 5 equals 45 minus 5n divided by 5n. So we took this division problem and we wrote it out like this. That's very important to do with all of these that are like this. And the next step, let me get my pen thing, would be, let's see, we would have, okay, so when I do this, go through here all the way down to right here, we had, looking at this, we had the 45 minus 5n, and then I rewrote it over here and showed you the reciprocal, and we had 5 over 1 is eventually 1 here. Then I switched it, so right here, so I could get the reciprocal there. I might have said it wrong earlier, but then we had 45 and 1/5 times 5n and 1/5. I rewrote it before I started marking on it down here, and then I factor out, forgot the r here, I factor out the common term of 5, which was my yellow markings, and I'm left with an n right here, and when I took out the 5s and factored out the 5, I end up with 9 minus n there. Now, another thing to remember is your doubles that end up turning something into a positive. So if you look at number 47, that's negative 44 minus 8t divided by negative 4. And so in this case, we do the same thing. I rewrite the equation here into an expression. I get the reciprocal and multiply that out. I'm then going to find the common factor and start eliminating start eliminating, and then we would have, end up with equals 11 plus 2t. So this sound, I mean, this sign isn't something when you're glancing at this that you're going to think automatically. That it's easy to not get that two negatives equal a plus. You got to watch this when you do the equation. So in this one we have the directions. This was from page number 63 on page 118. And it says, write this sentence as an equation or the equality. Let x represent the number. And the actual problem was the product of 2 and a number greater than or equal to 2. And so to be able to do this, you have to break the sentence down. So we want the product of 2 and a number. So we can say that's 2n. That is going to be greater than or equal to, so that's going to be that. And then the last part is the 7, and that would go there. So that's how you would rewrite this equation. Okay, so I just quickly want to go over something that was on, like I said, that earlier, that kind of jumped ahead from 116, where it's asking you to simplifying complex fractions. And this is the fraction negative 6 over 1. It's actually negative 1/2 over negative 1/2. And hang on, I forgot my little negative signs. It's not going to make any difference, but hold on. Okay, I wanted to go back in and put, with using the red marks where the negatives were that I left out. So we had negative 6 divided by negative 1/2. We take the reciprocal of that. We have negative 6 times negative 2 over 1. I just added this part right here just to keep it going. We end up with 12 over 1, which is 12. And because we had 2 negatives, that is a positive 12. Okay, the other thing I want, this is from page 117, questions 49 through 52. I may have already said that, but when you find, asking you, when you find the domain of the function, your answer should read as this: all reals except like when x equals negative 2, or when x equals 0, or whatever, or 1 maybe. And or maybe it just says all reals. They're all reals because there's no exceptions. But make sure that you writing out the words that go with an answer, not just sort of abbreviating and putting down, x equals negative 2. Make sure you're putting the whole kind of sentence down there. So let's take a look on page, and then on 118, questions 65 through 70 were a little tricky. Number 69 was 5 minus 1/2 minus 1/4. We rewrite it as 5 plus negative 1/2 plus negative 1/4. We now have to make the bottom numbers even. So we're going to get this one to match. So we're going to end up with multiply. 2 times 2 will equal 4. So, and 2 times 1 will equal 2. So we have negative 2/4 plus, we don't do anything to this one, so now these match. So now we can continue. And then we have 5 and plus negative 2, negative 1 is negative 3 over 4. And now we can turn, let's see. So now I'm going to make these equivalent fraction by multiplying this by 4 to get that. So I would have on top 5 times 4 is 20 over 4 plus a negative 3/4. That will give me 17/4 or 4 and 1/4. Don't go ahead and make this a decimal. There's no reason to do that. If you're ever in doubt, like, am I supposed to go ahead and convert it, then do both. But if you have a fraction here, don't just automatically convert it to a decimal because you don't know. I mean, there's no reason to do so. So either keep it as the fraction or show it both ways. Okay, so on quiz 3, number 13, that's page 118, we had a problem that was negative 28 divided by, in the parentheses, negative 2 and 4/7. I rewrote that right here, and so turned this into an improper fraction. So we had negative 28 divided by negative 18 over 7. And I did the reciprocal of it and just added this part just because that's the way I do it. So I have 28 over 1 times 7 over 18, which equals 196 over 18. I can divide this whole thing by 2. So I would have 196 and reduce it by half, or by 2s, divide it by 2, and I get 98 over 9, and that is my answer. Okay. Still on the quiz, this is number 17 on page 118. We have 9x plus 1 over 3, negative 3. And this is already simplified because the term 1 is not divisible by 3. So we can't go any farther. It's just like the one I showed you earlier where we had an each there. I also want to talk about, let's say that you end up, if you was working through a problem, something like 9x plus negative 4. Well, that isn't completely simplified at this point because we got 2 signs still going on. So to solve that, you would have 9x minus 4, okay? So you have to go all the way. You can't leave as your answer this kind of stuff. Okay, a couple other things I want to talk to you about is absolute numbers. When you got these lines right there. So in this case, b equals 12. Because the signs don't matter with absolute numbers, both the negative 12 and 12 is the answer for that one. Okay, and your assignment 4, which is page 116 to 118, you need to do numbers 32 through 38, 47, 68, and 70. Quiz 3, number 18, test is 125, is on pages 125 to 126. You're going to do numbers 25 to 38, standardized test on page 126, numbers 12 and 13 on that. And I just want to caution you on all of these assignments that these are basically a redo of ones that you have missed, but you need to get them all right, okay? Don't rush through these.